Okay, so what order? Let's do this in the order that the pictures are. Okay, which is probably pretty random. Yaniv, you want to tell us who you are and how you're changing the world in this sort of distributed Web3-ish way?
Yeah, I love to, Sandy. So I'm Yaniv Altshuler, and for the past decade, what I was doing was developing ways to analyze encrypted data. Namely, how to take large data sets that are very sensitive or that the data owners don't want to disclose or are forbidden from disclosing, and still allow them to be analyzed in order to predict trends and find correlations. And this is very useful for companies in the spaces of financial, like banks and large retail companies, companies that have different divisions that are many times not allowed to share data with one another, but they still want to benefit from this aggregation of data that the organization contains. And we are helping companies like Coca-Cola, Walmart, MasterCard, other companies to analyze their data streams. In addition, I am an advisor in the Israeli Ministry of Defense, where I am doing AI for digital transformation. And what this actually means is taking AI out of these exotic niche, very interesting, but limited in size projects, and finding ways to deploy them at scale, finding ways for the large organization, for different agencies, for different parts of the military or the Ministry of Defense to collaborate with one another. And very recently, I founded Metha.ai, where we take the same concepts, the same technologies, and use them to significantly reduce methane emission from cows. It's somewhat of a twist, but it has a connecting thread that I'll elaborate later on. But yeah, using AI to analyze cows' microbiome and reduce methane emission.
So that's intriguing, going from Israeli Defense Force and MasterCard to cows and methane. We will ask you more about this, I guess, in the future. Let's see, next in the list here is Jason.
Hi, I'm Jason Paragas. I'm a virologist by training, and so getting into the tech world is I'm a perennial student. I spent about 20 years in national security or health security with the U.S. government. I worked for NIH, the Department of Defense, the Department of Energy, but really looking at how do you take these really existential problems in health and then use technology to make them non-existential. And so it was a really interesting training to start to watch how technology is coming into our world. And so about 3 or 4 years ago, I got the bug, and I joined a startup in Boston, an AI-based startup, and have really saw the value of really bringing technology into the health, life sciences space, but understanding that health and life sciences, the biggest problem may not be data, it may not be algorithms, it may not be sensors, it may actually be the social engineering or social physics of the business. And so recently I'm building a new biopharma, Web3 native, that's really going to, as I think some of the speakers earlier today said, you know, Web3 is not a step function, really. It's an evolution of a lot of these different technologies that have been going on for the last 15, 20 years, and getting us into a place where now maybe the social physics of how we build drugs, how we bring drugs to patients, how drugs work with the financial systems, these sorts of things, maybe now is the time to reimagine that, re-engineer it in a way that we can bring drugs much faster to the patients, much faster to you, me, everyone, in the same way that we bring consumer electronics in the order of months instead of decades and billions.
We can certainly use that. Okay, Aaron.
I'm Aaron King. I work for Foresight Institute as their research director, and I'm spearheading this project. I'm interested in longevity, and one of the bigger things is like, what is longevity? What's going on there? And so we're spearheading this project to map out the entire space. So it's like a graphical Wikipedia almost. It's like, what are all the technologies? what are the companies and the labs and the advocacy groups operating in any particular domain? How do they all connect to each other? If there's a breakthrough that happens over here, how does it cascade through the system? What does it destroy? What does it create for the entire field? And this is very interesting, and it's pretty intuitive way of mapping out all the information. And so now, because the first one looks like it's working pretty well, we're doing it for other tech domains that Foresight's interested in. But technically, like, this could be applied to almost any industry. You just try to see how things would change if certain people achieve success in the field. And there's Web3 applications for creating incentive structures within this, and to also like governance Web3 mechanisms for how to even build these maps of the whole field. So that's why I'm here.
So it's sort of I'll call it almost like a regulatory framework, or...
We call it like a tech tree because it looks a lot like, I don't know if any of you played Civilization, but these are like technology trees, and you can see how they're all connected to each other and what feeds into what else. And it's just, and the idea is to make it interactive and digital and dynamic so that you can have it update, like Wikipedia almost, except graphical.
And would you use private data, like both of you? You're talking about this sort of merging disparate information sources to look at interactions. But is this something where, the notion behind Web3 is I don't actually give you your data, maybe I give you statistics about my data or something like that?
That's a possibility. We're dealing with public first and there's just a lot of it, so that's but then there's no reason why we couldn't try to have those mechanisms get integrated into the whole system.
Okay. Kevin.
Hey, I'm Kevin Esvelt. I run the Sculpting Evolution group here at the Media Lab. We do a lot of biotech development. We specialize in ecological engineering things that can spread on their own in the wild. So we have a project to edit the local mice so they can't give ticks Lyme disease, and then the ticks won't give us Lyme disease, to give one example. So we spend a lot of time building trust with communities because, as you can imagine, genetically engineering wild things makes people a little uncomfortable. But also, what makes me a little uncomfortable is the fact that we can engineer things that can spread on their own in the wild. And of course, you say, well, something that can spread on its own without help, it sounds a lot like a pandemic virus. What about when we do that? So the flip side is where our mission is to advance biotech safely. And the question is, what are we going to do when in 10 years, tens of thousands of people with skills like mine will have blueprints for the next pandemic? And they can make it single-handedly. That's also the future of biotech, unless we act to do something about it. So we are working on DNA synthesis screening systems that use this key server network that uses distributed oblivious pseudorandom functions, so you can just hash bits of the orders and compare them to a hash database of hazards without disclosing what's in the order or the hazard. And longer term, I'm interested in this question of, okay, I run a lab. We do a lot of stuff that is not actually dangerous, but looks pretty dangerous. What's going to happen when we're required to get insurance to make sure that our stuff doesn't go wrong? How can we verify that the stuff we're doing is not dangerous, that there's a record of it everywhere, all the things that we've ordered, all of the DNA that we've ordered, that we can keep private, but might be available to, say, an insurance auditor that can determine how much we should be paying when we're trying to factor in these negative externalities of the downsides of future technology.
So again, it's this sort of private data from all around the places, and now what you're trying to do is, with the private data, compute things that let you certify this as being safe or edgy or insurable or send over the troops, right? Whatever sort of thing. Is that?
That's the vague idea, but again, I work primarily with DNA, so I'd really welcome people's creative thoughts and ideas as to how we can forge a safer future of biotech.
Right, good. So Yaniv, cows.
Yeah.
Tell us about cows.
So, cows. Cows.
DNA maybe, right.
Yeah, exactly. For those of you who haven't seen a cow up close lately, cows burp, and they burp a lot. And this may be funny or cute or annoying if you're in a closed room with them, but actually it has a much more severe effect because cows are the single largest pollutant of methane, largest emission creator of methane. And methane is much more dangerous to the environment than carbon dioxide. And the problem is that we're not going to stop drinking milk or eating meat anytime soon. We are working on replacement, on lab-grown meat and so on, but it's not going to be readily available anytime soon or affordable at scale. So we need to find some solution for the, let's say, coming 20 years until those techniques actually mature. And when you actually look closer at the cows, what you realize is a cow is much like a car. The cow is the chassis, and it has an engine inside it. And the engine is the microbiome, the microbes that lives inside the cow's gut. And when the engine goes out of tune, then the car drives slower and uses fuel less efficiently and produces black smoke, and the cow does the same thing. It creates less milk or less meat from the same quantity of food, and the excess energy is getting discarded as burps. And these burps constitute around 20% of all global methane emission. And the problem is that given a cow that burps a lot, we don't know a priori if this cow is going to produce a lot of methane or little methane, and we don't know why. And there are plenty of products out there. Some are based on seaweed, some are based on garlic, some are based on specific microbes. And if you take one of them and try it on a cow, for some cow, it would work, reduce methane up to 90%. For some cows, it wouldn't, because you cannot take this one-size-fits-all approach. It's like saying, vitamin C is a good thing, let's give it to everyone and everybody would be healthy. It doesn't work this way. You need analytics. You go to the physician and you tell them what's wrong with you, and they run some exams, and then they tell you, well, you need antibiotics, and you need, whatever. But with cows today, it's impossible to predict the amount of methane and the causes for this emission. And there aren't any technologies that can do this. And this is where we come to play, because we can take a sample of the cow gut microbiome, send it to genetic sequencing, and then look at these raw pieces of DNA, analyze them, exactly with the technologies that can analyze sparse, encrypted, large data sets, and predict if this herd is going to be producing lots of methane, or if this is not the case and this herd can be left untreated, and why, and what is the best treatment for this specific herd. So in this sense, what's interesting is that it's much more of a computational data problem than a biological problem. All the mainstream attempts of analyzing microbiome always say, let's take the microbiome data, the DNA, and map it to what we already know. We have a library of several hundreds known microbes, so let's throw away 90% of all this DNA, take just what we know how to use, and look at what we got. But naturally, this cannot teach us new things. And as we all know, there are hundreds of thousands of possible microbes, and there is this long tail distribution where the interesting stuff is actually located. And by definition, if we take the mainstream approach, we can never find those new interesting stuff. So with this approach of looking at the raw DNA data, treating it as an encrypted, sparse, noisy, large stream of data, we can actually, for the first time, predict methane emission and predict treatment efficacy. And this is the idea.
That's sort of cool, I have to say. And it's not so dissimilar from what Kevin is doing. Kevin's taking these sort of samples of like everything in wastewater, right? And trying to ask, are there bad things in there out of all the bajillion of things that are floating around in that?
Yeah, and though that's a politically incorrect thing to note, so the general idea is, look, what do we need to fear? We don't know necessarily what the next virus is going to look like. Certainly any competent adversary is not going to make it look like anything that we are looking for. But the one thing that the next pandemic or equivalent event will have is it has to grow exponentially. So if you just sequence everything, particularly wastewater coming out of places like airports, and you just look for patterns of unique fragments from your sequencing data that get more common or appear in many nodes throughout the network, then that is a characteristic of something novel spreading through airplane wastewater and possibly air filters on planes that is indicative that we have a problem. And this extends to the environment, right? Now we can build a gene drive system using CRISPR in an organism, let it loose, and it will slowly spread through the species. That one at least is fairly slow, obvious, and easy to block, but you still got to look for it. Well, what if we sequence the Charles River and look for signatures of gene drive, which is always CRISPR, which is normally never in a sexually reproducing organism unless a human put it there. And then it should be in a genome fragment where a sequencing read has this turn me on in a eukaryote, which CRISPR normally is not in. So you just look for that signature and you'll find it anywhere. But does that mean you want everyone to know the sequence of all the DNA that you just generated? Maybe you're in a private partnership and the biotech that's funding it wants to keep that data to themselves for mining, of finding new tools. Maybe there's security reasons.
Yeah, I mean, the sort of general thing is that DNA data is very private. So when you take it, for instance, to drugs, right? Drug delivery, drug development, you can't be sharing all the individual's DNA. Or if you're going to try and treat a microbiome, which is a really interesting frontier, you can't sort of, you want to keep that private. You can't analyze everything because you don't know what everything is, et cetera. Yeah?
So it's worth noting that we could probably pick up each of our genomes just by swabbing the mic after this talk.
Yeah, no, it's interesting to see how microbiomes spread just like ideas, yeah. So can you tell a little bit more about how you're doing what you're doing?
Well, we're still stealth. We haven't printed our hoodies yet, so I won't go too much into detail. But broadly, you know, we're thinking about what do you make, what are the relationships, what are the transactions that happen when you make a drug, right? So there's company-patient transaction, right? You know, there's some sort of deal to get your data. Usually it's a bad deal for the patient, but there is usually some deal. There's a intercompany transaction, so between pre-clin and clinical. How does that drug make it from A to B, right? There's a transaction between a scientist and a machine, right? There's going to be a transaction between a machine and a machine. There's a transaction between a machine and an AI machine, so to speak. So there's if you really decompose what drugs are, they're really a knowledge. You know, you're really writing a journal or a novel that's composed of hundreds of thousands of transactions. So what is that? That's Web3, right? And increasingly, the human aspect of the transaction is not the sole player anymore. So if you look at the big table of who's at the table of pharma, you know, I was working on AI problems about, you know, for the last 15 years or so, and one of the most the story I tell all the time was I was at a very profound organization. I was very honored to be there. But the person that ran desktop support, so if you lose your password, you call him up and say, "Hey, I need a new password. I forgot that it's 1, 2, 3, 4, 5." Right? He also ran AI, right? It was they looked at the view that IT was AI. Okay, and actually, it's still true to this day. But what we were arguing at the time was that AI deserved a seat at the drug development table in the same way that clinical did, in the same way that the finance people did, the same way that the marketing people did. And so I think what you're going to start to see is that that table is going to be democratized by Web3. Who's the patient at the table? You know, who represents the patient rights? Who represents the payer rights? Who represents all these different things? And so it's really just a series of transactions. And Web3 really enables that, takes out the friction to really bring these drugs to market faster. And then if we can really do something in speed because of friction, I think we can really change access. We can really make a drug of N of 1 a reality.
So just to put it in the sort of the language of Web3, you're talking about private data stores with smart contracts between them, right? To be able to, you can use this piece of my data or you can use that statistic to be able to put them together to enable other sorts of transactions.
So I look at it more as a hybrid. So I think there's a lot of discussion around what a private data or proprietary data is. But there's massive public data sets that are incredibly valuable. There's a massive world of public algorithms. There's a massive world of private algorithms. There's a massive world of private and public knowledge, right? And so it's really that interplay between all these different stakeholders that a smart contract can enable very quickly.
Yeah, I was just trying to get at what makes this different than, oh, we just have a big database with a bunch of,
Yeah, I think if I was to kind of blast forward into the future, I think this whole idea of the data lake, I think is an antiquated idea. I
Yeah.
think it'll go away.
So within corporations, you see people finally come into that realization that most of their cost is in creating and cleaning the data lake. And there are these things called data fabrics now, which are essentially interfaces to all these separate things that allow you to do the same thing, but cheaper, better, faster.
If you look at if you just are ruthless about it, and you say, okay, well, what's the quality? If I look at the data from the past 10 years, so I look backwards, and I look at the data, and I say, okay, well, what's the quality? What's the veracity? All the classic descriptions of data, right? And the other thing that people a lot of times don't appreciate around data is a lot of times these data sets have contracts associated with them. It came from an acquisition, it came from a merger, they bought the data, they leased the data, there's some
I
sort
see.
of so these data sets, even though they may look like one giant data lake, they're actually incredibly holy and very difficult to use, right? If you were to look forward and say, okay, well, what would it cost me to generate that same data set in a year? You're going to get a much better data set, and it's probably a lot easier. And so forward-looking data versus spending all that effort.
So it's integrating the sort of legal ontology and characteristics with the data so that it's sort of smart data.
Yeah, I think you really have to start thinking about it less like data and more like knowledge, right? So it could be an algorithm, it could be a single person's data. It's really a transaction of an idea or a concept. Or
And so how does this all play out with Foresight?
Well, I guess it's a matter of contextualizing information in the bigger picture. So when you guys, the audience, are listening to all of us talk about what it is that we're doing and there's potential breakthroughs here, the question becomes like, okay, to you, like, what does that mean? How's that going to change the world, or what's going to be different? It's hard to figure that out, and I have a really good example for this, which is back when the algae biodiesel was going on. I was kind of waist deep in the renewable energy industry at that point, and we had to pay attention to all these algae companies and whether they would succeed or not, and so we tracked what they were trying to do. And so many of these people, they would run around and they thought that they were solving the problem because they didn't know it was the extraction process, the energy efficiency of the extraction process. That was the real bottleneck for that entire field. So they would run around, they'd be like, oh, we solved the land use thing. Oh, we solved this other part. And it's like, well, that's great, but you're still going to fail once you get to this one point that everyone else fails at. So it'd be really nice to know what the true bottlenecks of any particular field are, so you can say, okay, yeah, they're doing this, and did they solve the real problem, or are they just kind of solving this peripheral thing, and then they're going to hit the real problem, and then they're going to fail like everybody else. So we're trying to build a system that can identify those things, and you can do it in a centralized way. That's been done many times before, where you have these think tanks and whatnot. I think you can also do it in a decentralized way where you use the tools of Web3 to sort of bring all this information together and see crucial bottlenecks emerging, and then you can focus effort on those bottlenecks. You need to identify what the bottlenecks are, and then also what success actually looks like to solve those things. And I think that's pretty important in it.
So the thing that reminds me of are the people that are using Web3 techniques for logistics chains. So you have this very branchy train, if you have these pieces and these materials and so forth, and nobody's going to share their data with you.
Right.
But you have to be able to say, when is there going to be a failure or a collision in this chain? And so what you need to be able to do is somehow have things that you can run on local data that you can use then to predict the dynamics of this whole system.
Yeah, and it's going to be difficult. Getting the public-facing data first is okay. There's a lot of data out there, but then the true value is probably going to be in privately held data, where it's like you need to figure out, what's going on behind closed doors. And it's not that necessarily that people don't want to share the data with you; it's that they can't because of external systems that prevent them from talking to other people because of legal reasons or other sorts of proprietary things. So if you could have a system to get at that information without revealing the nature of it in certain specific ways, then that might be able to create, give you bigger picture and understanding of what's going on without necessarily violating legal boundaries that people in
That might
care
be
about.
sort of a good summary of a lot of what we're hearing here, or at least one abstract point. We have just less than 3 minutes. You want to just sort of go right down the list here and say, what's the one thing people should take away?
Every data project, every machine learning project is only as good as the data it is based on. Specifically true in biological application, clinical trials, because data is scattered around different stakeholders, different organizations that are forbidden from sharing the data. So they need a solution in a sense of a technology that can allow them to achieve the ability of federated learning, enjoying from the aggregate of data without disclosing what they're interested in and without disclosing the data that they possess. And Web3 is an ideal infrastructure for this.
Kevin.
Everything is evolution acting on data. Us, our thoughts, culture, ideas, you name it. That's what it all is. And human society works on the game theoretical level, determining when you should cooperate and when you shouldn't. That is trust. And as technology becomes more powerful, we are going to need better and better systems for evaluating all the available data, and possibly generating new data to determine who and who is not trustworthy in various ways across different spheres of life, in ways that don't create a totalitarian nightmare, but nevertheless prevent people from misusing increasingly powerful technologies. That's the fundamental challenge of the next couple of decades.
Context is really important. We need to figure out, why it is that we care about the things that we care about and what impact it's going to have, and what things we can do to speed up or accelerate progress in the best way possible.
Sir,
I think
wrap it up. Take it home.
Web3 is going to radically change all our assumptions in health.
Okay, good. Well, I
Still have
hope that
40 seconds
The
left.
healthcare system really sucks, I have to say. Okay, well, thank you all very much. Let's give them a hand. And we're on for the next panel. And Jeff is running it, right? Yes. Okay.